Hello, my name is Adeline Hall, and I'm with Marcello and we are currently in the Advanced Physics class in Period 5. Today, we're going to show you how to create raw data tables, data processing tables, and scatter plot graphs. First, we're going to start with raw data tables. Initially, a raw data table is where you organize the data you collected in your experiment. In this table, you are going to put the units of your independent and dependent variables in the header to show that the rest of your values recorded in this table are all in the same units. Second, you will put your trial numbers in the header and your values for each trial in the body of the table. You should have your independent and dependent variables labeled in the header as well, and be sure not to include any averages yet. This is an example of a raw data table. The independent and dependent variables are labeled in the header along with the units for each. In a raw data table, you want to show what happens to the dependent variable as the independent variable increases. That way, it's easier to answer your experimental question with the setup of, as IV increases, what happens to DV. Next, we're going to move on to data processing tables. You may be wondering, what's the difference between these two tables and why do we need both of them? Whereas a raw data table shows all of your values for each trial, data processing tables show the averages for your dependent variable trials, making it easier to make conclusions, show final results, and see trends in the data. These averages are the data that you'll put into your scatter plot later. Here is an example of a data processing table. It shows the averages for each increasing unit of the independent variable and how the dependent variable is affected as the independent increases. Just like before, the units and variables are labeled in the header. You may have noticed that the units changed from centimeters to the SI unit of meters. Your experiment may use SI units throughout your data collection, but if it doesn't, a good time to convert into SI units is in between making these two tables. I suggest finding the averages in the original units first, then converting those averages into SI units, to avoid having to convert all of your original values from the raw data tables into SI units. You may also notice that this example has a column for scientific notation. It helps to use this form when dealing with very small or very large numbers, but typically, data processing tables only have two columns, one for the independent variable and one for the dependent variable.
Next, we'll move on to scatter plot graphs. Each of these graphs needs a title to show what you're measuring, and should also have labeled axes so others looking at your graph know that they're comparing. Your axes should have both the units you worked in and have values marked along them, so others know where the points fall. Finally, make sure to not connect your points with a line, because doing so will imply that you collected data in between all of your points when you only have data for a certain amount of trials. Typically, we use Desmos to make a graph. First, go to desmos.com and create a new graph. In the upper right corner, click on the plus sign, then click Table on the drop-down menu. From there, you can enter your data from your processing table with the independent variable on the x-axis and the dependent variable on the y-axis. Once you enter those points in the table, they will show up in the graph. Make sure to label your axes once you put the graph onto your presentation and don't connect the dots.
Thank you for listening. If you have any further questions, please email us or schedule an appointment with us and Mrs. Taube in office hours. Thank you.